Good afternoon, everyone. We're going to wait one more minute and then we'll get started. Good afternoon, everyone. Welcome to Duke's Smoke and Dye Testing webinar. We appreciate you taking the time out of your busy schedule to join us today. I head up marketing at Duke's, and I want to take an opportunity to thank Caitlin for managing all the logistics for today's webinar. And I'm honored to introduce our speaker, Mike Ping. Mike is the National Technical Manager at Duke's and has over 24 years of extensive experience in the wastewater industry. He's a licensed professional engineer in North Carolina and South Carolina and graduated from Clemson University with a degree in electrical engineering. Mike's going to explore the techniques of using smoke and dye testing as a diagnostic tool to identify critical issues within your sewer collection system infrastructure. We encourage you to submit questions throughout the session using the Zoom Q&A feature. Once again, throughout the session, we'll address all those questions at the end of Mike's presentation. So as we move along, just please feel free to submit those questions. And if time permits at the end, we will provide an opportunity to open up the mics. And if you want to ask a question live, the only thing we'll ask is you'll need to raise your hand and then we'll unmute your mic. So once again, thank you for joining us today. Please join me in welcoming Mike Ping.
Thank you, Mark. Can you hear me okay?
Yes, we can.
All right, very good. We'll just jump right in and get started here. Again, I'm Mike Ping, and serve as a National Technical Manager here at Duke's. So the topics here, about 5 or 6 or 7 minutes each here, is we'll do kind of a run through of the company, just a company introduction, services overview for a few minutes. And then we'll jump right into smoke testing, kind of the what, why, and how. We'll start at the very, very beginning with the very basics and just kind of run through what those projects look like from setup, the reasons why, all the way to kind of what the deliverables can look like. And then we'll conclude with dye testing and then do any questions after that. In total, this ought to be right around 30 minutes total. So I don't think we'll run the full hour unless there are lots of questions. So to run through kind of the wheelhouse here, I'll begin with chemical root control. The Duke's name is synonymous with chemical root control. And if you look at the bigger picture of all the pictures here, that's kind of what it looks like. It's the application of an introduction of an agent in the sanitary sewer collection system to kill, mitigate roots. And that this has been going on for 30 plus years, and it's the origin of the Duke's company. So lots of chemical root control going on, hopefully to mitigate. If you look in the middle here with this guy with the bright yellow suit on, where he's I don't know why, but he's bear hugging a giant root ball here, and those things are very costly and so forth. And so chemical root control is a typically applied as a program to mitigate against that sort of thing. And that's the chemical root control. I'll go ahead and mention is the subject of the next webinar that will be going on here in a month or two, and I'm sure you'll get an email for it. But the next kind of group here is the monitoring services. We offer lots of services associated with it, kind of working around the wheel here is open channel flow monitoring or area velocity flow monitoring. We do lots of these projects. It's a growing part of our business. We've got pump station telemetry and equipment and services that we offer. Then at the bottom, what we call micro detection. That's level only studies that are typically used for inflow and infiltration studies. And then the last one over on the left there, this overflow alert, which is a simple kind of just standalone monitoring system to provide email and text alerts. We have lots of TV pipe cleaning going on, many crews throughout the country. This is a photo of a more challenging application, but just to emphasize that we've got the ability to do off-road. This picture here, it's one of my favorites. That the pipe that's being cleaned is over on the right, and if you see in the middle of the picture, there's the kind of that black wheel that's called an easement machine, which in effect is a hose extender to jet and so forth. And you can see the guy climbing down the hill where the combination truck is way off to the left. So we offer lots of this. We're doing it day in, day out around the country, and we really pride ourselves on providing what I would term a proper DASCO deliverable set. And we sometimes do condition assessment reports on top of that. So that's a key piece of Dukes. Kind of along those same lines, manhole inspections. The deliverable package kind of runs in parallel with TV. A lot of similarities, but the hardware for manhole inspections is always improving. Kind of like iPhone cameras. You can see here, it's an excellent picture. But these part of the package is a 360 video, and we're doing these kind of projects every day, small ones that are 50 and 100 manholes, all the way up to many thousands of manhole inspections. We do acoustic pipe inspection. This is with an instrument called SLRAT, which stands for Sewer Line Rapid Assessment Tool, and it's a test to for smaller diameter pipes for checking for conveyance capacity and ultimately debris and a need for cleaning. We're doing more and more projects that are more program oriented, where we combine this and manhole inspections and some other things, but that's something that we're doing. Rolling down here, large pipe MSI, or multi-sensor inspection as it's called. This is the more sophisticated. Large pipe would typically imply, I'd say 36-inch and up. It could be 30. Actually, it could be a little bit less than that, but typically it's for bigger, more critical infrastructure. And these platforms typically have sonar built in to quantify debris below the water level, laser for measuring, and sometimes LiDAR to kind of really do a point cloud kind of survey inside the pipe. So it's a sophisticated platform, sophisticated deliverable for critical infrastructure. And then these two pictures, kind of the before and after, we offer both sectional and top hat lining. So it's kind of self-explanatory here. This is not manhole to manhole lining. This is kind of the point repair, 4-foot type liners for repairs and so forth. So that's kind of an overview of our service offering. So jumping into smoke testing, I put this in here. So this is, a clip from the EPA Region 4 guide for collection system management, operation, and maintenance, which there's an acronym called that's CMOM, CMOM. But this is just to kind of establish that smoke testing is a widely recognized methodology, tool, test, so to speak, to locate what's called I&I. We'll get into that. But it's something that's been going on for quite some time in the industry and continues to do so. So it definitely, it's a time-tested methodology, and it's something that generally makes sense for a lot of utilities to be doing, at least at times. So I mentioned that we'll start with the basics, and this is about as basic as you can get here, right? So it's the basics of a complete system. So going left to right, we've got users of water. Those would be houses, industries, whatever the case may be. A service lateral flowing out of that into the public sewer collection system, the sanitary sewer collection system, kind of downstream to where the three guys are standing around the manhole structure, which is just a simple access point for the pipes. On to the right, over to a wastewater treatment plant, which treats the water biologically and then sends it on to the receiving body of water. So the key takeaway here is the collection system, the piping in the collection system, there is a max capacity, and that's, I'm saying it, a maximum flow rate in units such as gallons per minute. That's a fixed value, right? And generally speaking, it's according to pipe size and slope. There are other variables, but the bigger ones are the size, simply the size of the pipe and the slope, right? So those two typically cannot be changed, of course. Like you can't hit a button and increase the pipe size. And the slope is set according to the system. Like these are all networked together. So it's not possible to change the slope without changing all of the upstream or downstream system. So just keep that in the back of your mind here. And to take a look at some examples of what's called INI, or inflow and infiltration. That's synonymous with the smoke testing. That's the reason that this is happening. And these photos on the left are good examples of what INI can potentially look like. Starting in the bottom left, that's a photo from inside of a manhole where there's obviously like a high level of groundwater that's getting in cracks and so forth, and it's just getting right into the sanitary system. An open manhole, we've done studies where we've found these kind of off in areas that are overgrown or whatever, and the ditch gets full, and it's just a whole area is flowing directly into the manhole and the collection system. Then this top left, that's a curb inlet structure that's built for surface water to escape, and hopefully not into the sewer system, right? And then that top manhole that just shows water coming into the sewer. So these curb inlet structures, for example, they're specifically built to drain rainwater, or surface water, and ultimately that should make its way to some sort of creek, stream, or what have you there through series of channels, pipes, or whatever. But it is these days separate from the sanitary system, right? There are some combined systems, or CS, just combined systems, still around a little bit, and some utilities, especially the older ones, that are still working to separate those two, and those are good candidates for smoke testing. Yeah, so hopefully that curb inlet structure is not piped directly up to the sanitary sewer system. So applying a little bit of math to this, if you think about 2 acres, and that's probably a big area, but 2 acres, and here comes along a 1-inch rain event of some kind. Just doing the length times width times height volume calculation for a rectangular shape, that produces over 50,000 gallons of water. It's a lot, right? It's not so intuitive to go from that to think about, well, what does that mean for, let's say, this 8 or 10-inch pipe over here, right? So, if you think about 50,000 gallons, if the rain event, it's common, a couple of hours, 2-3 hours. When it's like that and it's entering the collection system in a shorter time frame, that can yield flow rates in the plus 250, plus 300 gallons per minute, and that's on top of the normal flow that may be 20, 30, 40 gallons per minute, for example, right? So here's the key: an 8-inch pipe, which is probably the most common size in the US. So an 8-inch pipe that's full, moving with a velocity of 1 foot per second, which would be kind of normal. It'd probably be kind of high, actually. That produces a flow rate, or yields a flow rate of 156 gallons per minute. So so what does all that mean? You introduce 278 gallons per minute on top of an 8-inch pipe that already has something in it, and that pipe cannot handle it, right? So it would produce backups, potentially overflows upstream, and so forth. But it's a problem, and that's just one structure, right? So you could do a smoke test and have 500 defects, right? Hopefully they're not all this severe, but this would be definitely a major one. But this stuff adds up, and that's the point. That's what drives smoke testing. So taking the same these photos here, what if we push and force smoke into this manhole, this same manhole? Like what would happen? Um, there would be the smoke is going to go everywhere where it's open, right? Anywhere where the air can go, smoke will go, right? So it's just being pushed up, certainly over to the left, right? And there we go. Smoke would be coming out of the inlet that's built to drain rainwater or stormwater off of the road, right? So that's kind of on the most basic sense what is happening with smoke testing. So getting into kind of the nuts and bolts of a project, communication is certainly a key piece to smoke testing. It's critical, right? So step one typically is a door hanger of some kind that has some basic information. These days we're putting QR codes so the recipient can pull out their phone and maybe watch a little video just to kind of quickly understand what's going on. Typically on the back, it's written out. We quite often have it in English and Spanish, and it's a key piece because you introduce smoke. If it gets into the house, people are concerned naturally, right? So these door hangers and the communication, sometimes it's Facebook communication. We try to work with the utility to do whatever is appropriate. Step two would be kind of the day of. The field superintendent or crew leader would notify on a daily basis the emergency dispatch just to let the fire department know, hey, there's smoking going on over here in this area. It's a courtesy to let those guys know. All right, so getting into how it works, you can see a machine. It's very, very simple. Anybody on this call could dial it up and order one of these things. They're not super expensive. It has like a lawnmower type engine. Crank it up, connect it to the special oil that produces the smoke. It's got a fan on the bottom of it, and it's blowing air and smoke inside the manhole, and that smoke is very dense. So it's just filling up. Typically, you kind of set up to where you can do a couple segments upstream, a couple segments downstream. Occasionally, we'll run into somebody that really wants to like sandbag the manholes, trap all of the air in one segment, and really put it to it as far as smoke density and concentration. I mean, our general belief is like that's kind of overkill. I mean, the machine can produce enough pressure that it could blow out a P trap in a home where the home is set up and plumbed up correctly, right? So you don't want to take it quite that far. I mean, kind of rule of thumb, couple segments upstream, couple segments downstream, and look at the footages. So once that machine is started, there's smoke being introduced and forced into the sanitary sewer system. And anywhere where there's a crack, kind of over here on the left here, there would be smoke. So the crew would start the machine, and then they're off and about looking for smoke, right? It's that simple. So we'll use this example here for a little bit. You see it coming out the storm grate there. That's very typical. I mean, it's not unusual, to do a smoke test of, let's just say 100,000 feet in round numbers. There'd be a handful of these. There'd be a mix of anything, downspouts, maybe gutter systems that are connected, broken clean out caps out in the yard, just a whole variety. But that's kind of a diagram of what this can look like. So question is, how accurate is accurate enough for logging the data? Quite often, we'll see specifications and it'll say something like, hey, survey the GPS survey where the defect is. And if you look at this photo, right, if you had a GPS coordinate of the center of the storm grate and you moved over and you were off by 6 inches, well, you're still on the storm grate, right? And realistically, the purpose of getting the location isn't to survey it, have X, Y, and Z coordinates down to a centimeter. The purpose is for the recipient, the utility, to understand where it is. And generally speaking, like a phone grade GPS coordinate and a photo like this is more than sufficient. I mean, you can see obviously where this is, right? I could drop everybody on this call a pin and we could all meet up there. We know where the smoke came out immediately, right? So not a big advocate of doing GPS level, high end coordinates for that. It makes the project expensive and complicated, kind of unnecessarily. And lo and behold, I'm prepping for this thing earlier today, and I noticed the picture on the left, the guy with his notepad out, and I grabbed that picture randomly off the internet. But that guy has a survey GPS at his feet there. So it's a good example, right? Do you need to, if you want to find the defects, are you going to need to pull out survey gear that's very expensive to find it? No, you're going to look at the picture and probably walk right up to it. So, but the point is the crew gets the machine running. They're usually in a 2 or 3 person crew, and there are people walking about looking for smoke and logging that information. And I'll show you what that can look like here. So an interesting example, we did a smoke test. I participated in it where, there's a really high end residential area that that never had standing water anywhere, right? So being higher end, it's not uncommon. They don't want standing water. So where do you see a pipe going through the yard, clean out cap, there's plumbing there, hire somebody and plumb it, but it's plumbed up to the sanitary system, right? So that's very common, right? So getting into data collection, these types of projects, similar to other kind of sanitary sewer projects, the field crew location details and the attributes of the data being collected needs to be collected into a nice modern electronic data collection platform. I mean, we certainly do that. It's kind of an example of it. It pulls up the address, but it ties all this information up so that at the end of the project, the recipient can receive the deliverables and understand immediately what's going on. This little map clip, for example, you see it, you see the little yellow diamonds, you know where your sewer system is with the green lines, where the defects are, and we'll kind of dig into what this can look like now. So kind of industry deliverables, to make a comparison, pipe CCTV has a very well-established industry standard deliverable, so much so that when you buy a CCTV camera, right, you have to put software on the computer that's running it. These softwares are built where they produce the industry standard deliverable. It's all that stuff is designated by NASCO, the pipe association that's part of this. But the point here is like pipe CCTV and manhole inspections, very standardized deliverable package, right? Doesn't mean it's always done correctly or incorrectly. And that's not the point here. It's just, it's very well established. So kind of just thinking through that here, this is for smoke testing, but realistically, any wastewater kind of analysis kind of project, there can be thousands of photos. For us, for smoke testing, we take 2 photos. So if there's 500 defects, there's 1,000 photos, right? Nobody wants to look through 1,000 photos, right? They want to find the heavy hitters, click on a handful of them, understand what's going on. There could be potentially Excel with hundreds or 10,000 rows or whatever, reports with lots of words and descriptions, paper maps that good or bad resolution. So all of that contributes to kind of the look and the feel for what is received. And I feel like it's a super key piece to have all that stuff like thought through before the project happens. Like, not all deliverables are created equally. The paper one here, my favorite example is I once had a flow report I was looking at for somebody that was over 1,000 pages, and it took a month to get through this thing, right? So probably the recipient just wanted to know, where are the large flows, have some kind of summary piece to it to quickly get to the information that they want. And that's the point here. The recipient wants information, regardless of what kind of project, to get to the next step as quickly and efficiently as possible. Bandwidth is more limited now than ever. So we talked about pipe and manhole. For smoke testing, there is no established standard, right? It could be you could hire some guy or a company that they could buy a smoke machine. They could be doing smoke testing. They could take pictures with their iPhone. They could write on a piece of notebook paper, I'm at 222 Main Street, and the pictures you'd have 1,000 randomly named photo files and some paper, and it'd be hard to get to come to a conclusion at the end of all of that. So I'm going to just show for a couple of slides here what it could look like, for example, when we do it. So this is a clip out of what we call Insight 360. It's a web-based, so there's no software, it's just web-based. It's a dynamic and interactive platform, right? So you can very simply, this is the result of a smoke test, right? You have the address over here. You can come over here, click on any photo, on any of the defects. The photos pop up, click on them, et cetera, et cetera. The point is this, just we've been on this slide for 20 seconds or 30 seconds here. I mean, everybody looking at this probably knows, well, there's a lot of defects, right? The red ones signify something severe. The green ones, much less severe. Orange, yellow in the middle, right? You know where they are. Can zoom in. It's Google Map based and so forth. All the distribution of defects are up there in the top right. A lot of storm sewer direct connections, clean out caps, et cetera, et cetera. So talking about the deliverables, it could have been notebook paper, and it could have been crayons and construction paper, right? You ultimately get down to it. So it's important to sew all this information up in a way where the recipient can get to it, in minutes. So we looked at the electronic version. This is the paper version that sits behind it. We have an access point in a file storage area. All of these are components within the report, but we've got professional level GIS maps. All the defects are labeled beginning at 1. So every project, defect 1 up to how many ever there are. This legend over here, what we do that's not so common is we rank the inflow potential, right? 1 to 5, with 5 being the largest, 1 being the least, right? And anything that's like this, that's designed, a structure designed to collect stormwater, rainwater, etc. If there's smoke coming out, our crews are advised that's automatically a 5, right? So clean out caps could be, if it's in a low lying area, it could be a 3. If it's up on a higher area and up off the surface, it's probably a 1. It's just to kind of, allow for the recipient to see the defects, kind of get a good taste of kind of the distribution of severity. So the key information that's collected is the defect type, the test number. One test could produce lots of different defects, right? So a project may be 10 tests and then there's 100 defects or something, right? Or there could be one test could have 0 defects. But you have the test number, the inflow potential that I just mentioned, the smoke intensity, and then the address. So moving on from there, just kind of a glimpse, even if a hard drive is provided, of random photo names. If you think about that, and you have a hard drive as the deliverable, and there's just a bunch of photos, and you don't know where they are, et cetera, et cetera. It's just not the same, right? So not a big advocate of that. Definitely an advocate for a deliverable vehicle that allows a utility to kind of get it within minutes, right? 10 to 20 or whatever. But generally speaking, one meeting ought to get you to the end. So just kind of the conclusion on deliverables for smoke testing. The field piece of smoke testing is pretty simple, right? It's not a camera system. It's if you can crank an engine, you can pretty much make it happen, right? So it's simple to do. However, be very mindful that deliverables that include lots of pictures, lots of data, aggregating that data and things like this defect breakdown over on the right, that's a completely different animal, right? That requires, professional level data collection. So, what are some potential challenges? Smoke testing certainly can have challenges. As mentioned at the beginning, communication critical, right? So, homeowners that are not cooperative, that always happens. So, the crew guys have to be properly trained to handle sensitive situations and so forth. The example I've mentioned before with the nice home there, at yacht in the backyard, that kind of, I mean, you can't just pull up in your F-150 and start wandering around somebody's yard. That generally does not go well. So lots of extra communication with the homeowner association, real estate kind of signs, information, extra steps, Facebook, this, that, the other, that stuff helps. Certainly hospitals, schools, schools, it's, I've participated in smoke testing projects around public schools. Obviously, you're not going to want to do the test in the middle of the school day, and requires a little bit of coordination with maybe a maintenance guy, the principal, or whoever, and schedule that guy for 6 p.m. or something like that, and make sure that they all are aware. Hospitals, you probably just avoid it, right? And then the data collection challenges, the location. We talked about the centimeters business and all that. Look, the collection of the location data is critical, and to not have it off by a street or to get that data jumbled up, right? Quite often, or I should say sometimes, utilities want to take this information, they take the address, they send a letter to the address. Hey, here's a photo, and you have, your gutter is tied up to the utility system's sanitary sewer. That's technically against the law. Please work to fix it. If that letter goes to the wrong address around the corner, that doesn't help anything. So, the aggregation of that data is very important. So to touch on cost, and by no means is this to say like here's what it costs or anything like that. Just this is just to provide a general sense of what smoke testing could potentially cost. I mean, really big jobs are, the unit rate of per foot, it's much less. And smaller jobs, it goes up. And certainly, as you might imagine, doing work in Los Angeles, for example, would cost a lot more than doing it in the middle of rural Georgia or something like that for prevailing wage and different factors and so forth. So, lot of smoke testing happening in this range, right? And production values are generally, 25 to 35,000 feet per day, right? So you can kind of do the math here and see, this can be a cost-effective way to find sources, locations of, inflow and infiltration that impact not only the collection system, but the wastewater treatment plant. I mean, that has a certain capacity range and flow rate where it can biologically treat. And, it's very, very expensive to increase those numbers, right? So smoke testing is a proven way to locate in a cost-effective way. So, kind of jumping over to dye testing. So, dye testing, on the most basic level, it's confirming that structure A is connected to structure B. Now, dye testing could take a number of different shapes and forms and so forth. And I'll show a couple, but I mean, it could be just recently we had a project where it was a flow metering project, and the flows didn't add up, and there were some things going on. So our crew put dye in a manhole way upstream, and then just followed where it went, and it went completely somewhere else than what the GIS was had established to be the case. So it was kind of a mapping connectivity exercise. So that could be dye testing. Generally, I&I is like some sort of a connection of or flooding of dye in a stormwater structure of some sort, and seeing if it makes its way into the sanitary system. So, and then by about how much, just by looking. So simplest of cases here, there's smoke coming out. Hey, we're pretty sure that the sanitary system is connected to this stormwater structure, but where, right? You're just not going to take a backhoe and start digging the road up, right? Need to know exactly where, right? So, the truck pulls up, and this certainly doesn't represent all dye testing, but the principle of it, right? So, yeah, kind of made some homemade things here to get the point across. But dye is entering the stormwater system where the smoke is had come out in the past, right? And it makes its way into the main, right? So there's a camera operator, there's a combination jet, vac truck, and this camera guy's over here, and he's going to drive up and see if he sees dye. He keeps going until he can't see it, and hopefully he can see where it's actively entering the sanitary system pipe, right? So he's looking over here on his screen. It says, for example, 157.5 feet can be measured off. It's known where it's the data is collected to know where the connection point is. It could be plumbed up, properly, right? It doesn't have to be a break-in tap. It could be plumbed up, and previous TV people maybe thought it was a standard service lateral sanitary. So just one example. This is an interesting example where very interesting actually. There's suspicion of what's going on. There's I and inflow and infiltration known. So it's like, where is this coming from? The crew takes some what appears to be some concrete bags, kind of makes a little berm, floods it, right? They're putting dye in, and you can see the red arrow. Boom, it's getting down through the cracks, through the dirt, straight in. And it's that stuff, as we showed in the early part of the slide deck here, these values can add up quickly. So this is substantial I here is what's shown. So cost examples for dye testing. When you start involving a full vac truck or combination truck, the big white truck that I showed on the and TV gear. Again, this isn't to quote anything, but you're getting into, these days that equipment's going way up. So the unit rate per day, it's substantial, but just to kind of toss some numbers around, just as food for thought, $4,000 or $5,000 per day. Maybe this crew can do a couple of tests. If you're filling up a stormwater pipe that's 24-inch, and let's say there's a gravity pipe below it, and you're suspecting there's a cross connection, lot of volume. It may take that truck several trips just to fill up the pipe and plug it. A lot of time and expensive equipment sitting around, 2 or 3 crew guys, right? So, one test could be, you can do the math here. It's not uncommon to do a connectivity dye test where you're in an apartment building and you're just testing to see where the laterals are connected, right? Where you're dumping dye in a sink or a toilet, letting that go down, and a camera operator is looking, that's a different scenario and much less cost compared with this. So that's it. I just want to mention the next webinar for Dukes is a chemical root control webinar, and it's coming up here in a month or two. And if you're on this, you're probably on the email list. So Mike Hogan is queued up to do that. He's been at Dukes for many years, and a guy that's been in the industry, a lot of experience. So any questions, and the email address, but thank you for participating. And Mark, I'll turn it over to you.
Thanks, Mike. Got a couple of questions. Mike, I'm going to focus on some that are associated with the webinar today, and then there was a few other questions that are sort of outside of that. So let's start with the ones that are associated with the smoke and dye testing content. One question was, how do they gauge smoke intensity and inflow potential? How do they gauge that?
Yeah, so it's a subjective value. Both of those are ranked for us on a scale of 1 to 5, and it's totally subjective. So it's just via experience. If it looks like it can collect a big area, if it were an open manhole in a ditch, it's a 5, right? So the intent, it's not super scientific. The intent of that is just to cross compare. Hey, here are probably the heavy hitters. Here are the ones that are probably not heavy hitters, right? To make that deliverable easy to look through. On the smoke intensity, it's just visual. There's nothing very scientific about it. Sometimes you see it's a good point, Mark. Like sometimes you see a storm structure that there's not a lot of smoke coming out, right? So depending on how you look at it, but look, if smoke can come out, that means water can go in a structure that is built to collect rainwater. So that one for us, we would still rank that a 5. It's just to try to help the ease of the digestion, so to speak, of the data on the back end.
Thanks, Mike. Here's the next one. How critical is soil moisture when smoke testing is conducted?
Yeah, that's a good question, and I probably should add that to the content here. But yeah, for sure, great question. You typically want to do smoke testing when it's dry, right? You don't want to do smoke testing when after on the east half of the U.S., definitely after a rain event where water tables all the way up to the surface, so to speak. I mean, the smoke won't get out, right? Um, so it would through an inflow area, but through the ground and so forth it won't. So short answer, you try to do it when it's as dry as possible for that specific location.
Mike, next one is how do you keep the smoke testing fan from creating excess smoke at the machine, creating a traffic hazard?
Yeah, that's a good question. Most of the smoke goes into the manhole. I've been out with the crews, some I'm not a crew guy, but I wouldn't deem it. I've never seen it to where it's a smoke hazard. Now, if there's a storm, some of those pictures of storm inlets where the smoke is coming out, maybe it could be somewhat of a hazard, but I don't see that being a huge problem that I've seen. So they're designed to blow the smoke in. It sometimes can get out a little bit, but hopefully that isn't happening. I would say if it were a hazard for traffic, you would try to move and put the smoke machine somewhere else.
Here's another one relative to Mike. What about smoke test issues coming up in basement floor drains?
Yeah, so if it just means that if there's a connection point and there's no P trap or the P trap is empty, and it's not uncommon in a smoke test to fill an entire house up full of smoke. Part of the instructions on the door hanger say, hey, make sure all of the P traps are full, run a little bit of water. So, you know, I don't know what the percentage would be. It varies, but a small percentage, there's going to be some pushback and some reactions from homeowner. It's part of the process. So I think the key is to do everything you can communication wise, and then be ready for the basement to fill up full of smoke, and make sure the crew guys are trained up, ready to deal with it, and get everybody at ease as quickly as possible.
And Mike, I've got two that are somewhat similar, but I'll differentiate them. Is there a way to quantify the amount of inflow infiltration from these tests, or is flow monitoring the only way to understand quantities?
Yeah, so good question. I had some of that content in here and I took it out for this one, but yeah, I've seen specs to where the requirement is to uh, have a flow value tied to this source of inflow. My belief is that the only way to do that would be with flow monitoring, except you're not going to know where the flow monitoring is until after, I don't think there's any way to do that. Short of doing a topography study survey and doing some sort of calculation like you would in the stormwater environment. But realistically, smoke testing is to find the bigger defects and to be able to form a plan to deal with them, right? To get that I&I number. And you're never going to reduce I&I 100%, but maybe an area that is producing a lot of I&I, maybe you do some work and it decreases it by 50 or 80%, maybe something like that. So I don't know. To short answer, I don't think you can.
Yeah, and then the other thing is, there was an early question, Mike, about, in essence, it was about monitoring, which is, how much are the standalone monitors, and is there a monthly fee? How does that work?
Yeah, so tied to this would be flow monitoring. They kind of these There's a natural kind of overlap, but flow monitoring hardware is expensive. I would just off the cuff say 10, 12, $15,000 per setup, and it requires a it's kind of like CCTV. You don't just hand that stuff off to anybody and expect great results. So a lot of training and experience is necessary, but flow data, area velocity flow data is relatively expensive. It's very dependent on the quantity of the project and the time duration. Those numbers could be as low as 1,000 per site per month to 3,500 or 5,000 per site per month. But a lot of projects that have 10 meters that are 3 and 6 months, maybe 2,500 per site per month would be kind of a ballpark number. Again, that's not to throw a quote out or anything, just to kind of ballpark it.
Like another one is, if a homeowner is connected to the sanitary sewer collection system with gutters, sump pumps, etc., how do we ensure they correct the problem? What are some best practices?
Yeah, so you're getting into an area there where you talk to different utilities and different people handle that differently. I could only state my personal opinion from being around this in the industry. I think having a plan where the utility just takes care of it as much as possible and has the homeowner sign some sort of release, and like there needs to be some communications that, look, we're trying to help you. You don't have to accept our help. If you want us to help, we'll do it. But if you don't help, you're going to get in trouble of some sort, right? So, and explain, hey, this is a problem, and you can't have your roof draining to the sanitary sewer system. In fact, it's illegal, right? So, um, I think like there's a kind of a common sense approach, but there are a lot of utilities that, hey, that's their problem, and we're going to put it to them, right? So, I don't know. I don't know that there's like a right or wrong answer. I just think like the utility is set up to deal with it, and homeowners don't know the difference between water and sewer quite often, right? So it's hard for them to tackle that sort of problem.
And Mike, I've got one more that was started early on, which was just a question about, does the foam root control kill or damage the trees?
It does not kill the I'm not the root control guy. You can learn about it on the next one, but like it does not kill the tree, right? It kills the roots, and the roots don't just magically disappear instantaneously, right? It could be this big root mass here that the guy is holding, right? But typically it takes, 30, 60 days. Those roots lose all integrity, and either the flow takes them away, or if somebody is TVing, the camera could bump it and it just sloughs off and goes away. But it does not go up and kill the tree.
Thanks, Mike. And then one final one, and then we've got someone who's raised their hands, but they also submitted a question. So I'm not sure, but the question was, who do we contact for quotes on smoke testing, or do I email marketing, or is there a
Yeah.
better contact? We're gonna be following up with all of the attendees with this, but we'll be following up. I don't know if Jorge, if that's a question you wanted to ask live or not, but we will be following up with anyone that's got it. So submit it through marketing. If you submit it through Mike,
It
we'll
comes to us. That
we'll,
email is
yeah,
to Mark and me and
yeah,
Caitlin. So we'll
we'll
get it.
get it in the right hands. But we will be following up with everybody to make sure that you have access. The material for today was recorded, and will be available. And with that, we do have just a couple of minutes but I do want to open it up if for any reason someone wants to go live, just raise their hand. I see, Jorge, you put it back down, so we answered your question. But if anybody else, um, okay, Jeffrey Tyler.
Yeah, can you hear me?
Yes, we can.
Do you know any companies that may be able to help with this kind of service? I'm joking. I'm joking. No,
Right.
Dukes is a big part of what we do here in Virginia. So I just wanted to say thanks to Mike
Well,
and
thank
sharing
you for
this
that.
important information.
Thank you for that.
For you guys that are considering smoke testing, I can tell you it's probably the most effective and inexpensive way of eliminating some of the extraneous flows that we all have to deal with on a daily basis. So I know your plant operators downstream would love to for us to do a lot more of this, but it is certainly the least expensive and most effective way to really. I have clients that literally follow my smoke test crews around when the crews are out, so they know exactly where the problems are and they address them immediately, which is fantastic. Uh, Not everybody has the resources and crews available to do that, but you can really kind of get a sense of where the smoke shows up uh, and why when it rains the plant gets inundated with flows. So thanks for sharing the kind of details. It's Mike was right. Dye testing and smoke testing and camera systems that we now have to see what these systems look like are game changers.
Yeah. Yeah. Thank you for
Thank you.
that,
Thank you
Jeff.
for that. Hey, Mike, that's actually there was one last question that um, I want to bring up. It's sort of a good one to sort of finish up on is how should utilities think about smoke and dye testing as part of their long-term asset management program and just not a one-time event? How should they
Yeah. So it's
uh,
a good,
yeah.
it's a good kind of the implementation piece. I mean, yeah, I would think like, look, all utilities are different. There's a utility I know that Jeff has worked with that has no pump stations. There are others that are full. I mean, there's all sorts of differences, but I think in general, smoke testing would be a great piece to do to have it under contract and do like a certain budget amount per year with the idea of like working around the utility, every X number of years. I don't know, it'd be different for everybody, but look, brand new neighborhoods do not mean no I and I. Quite often, that's where we see a lot of those direct connections. So probably something I should add for the next time we do this. But I kind of think it would be an annual thing would make sense. It's cheap and quite often it produces instantaneous kind of targets. I shouldn't say results because the result isn't until there's like a fix, but it could be a target and there's some good things out there for crews to work on, be it internal or external. Is that
Thanks,
it?
Mike. That's it. That's it.
Yeah.
So once again, we want to thank everyone for taking time out of your busy day. We will be following up and make sure that you got access to view this if you want to view this session again and see Mike do it a second time or share it with other associates within your organization. But I do want to thank everyone. Have a nice, safe day and looking forward to seeing some folks at our next webinar. Thanks, Mike. Thanks, Caitlin. Thanks, everyone.
Appreciate it.
Have a good day.